Hi guys, in this video I'll talk about limiting friction. It is the maximum static friction that can act. Okay, so when sliding is about to take place, this friction is acting. Again, the sliding is about to take place, it is not actually taking place. Okay, and how we can identify that the case is limiting? The use of minimum and maximum words are the hints that limiting case is present. So let's start with the first example. We have to find the maximum force for no slipping between M1 and M2. Okay, as the force is maximum, if force applied is greater than this maximum force, the slipping will take place. So we can say the slipping is about to take place. Okay, but it is not actually taking places. So common acceleration in this case, A common, is how much? F by M1 plus M2. Because the ground is smooth, so both are moving together with a maximum acceleration, which is F by M1 plus M2. And by drawing the FBD of the upper block alone, because this block is moving just because of friction, which in this case will be limiting, which is mu n, and n is nothing but m1g. So the friction force acting on it is this, and it is getting an acceleration, which is this A common. So we can say mu mg is mu m1g is m1 A common. M1 m1 cancel, we get mu g as F by m1 plus m2. So F max is nothing but mu times G m1 plus m2. This is the maximum force on the lower block we can apply so that both move together without slipping between them. In the next example, we have to find the minimum force to keep the block at rest against a wall. Okay, this is a wall, an external force is applied on it, and we have to keep it at rest against the wall. So we can say, drawing the FBD, we get normal mg, and as the force is limiting, as the case is limiting, the force acting friction will be mu n. Okay, and this force is minimum. So applying horizontal forces to balance each other, we can say F min is nothing but n, and vertical forces to balance, mu n is equal to mg. Putting the value of F, we easily get F min is equal to mg by mu. So this is the minimum force to keep the block at rest against the wall. So what if F is greater than F min? Obviously the block will not slide, but the friction force acting will be mg alone. Okay, because it has to balance the weight. It should not happen if F min or F applied is greater than F min. Obviously the available friction, again I'm using the term, the available friction is more than its weight, but it will not act completely, because if it acts in upward direction, the block will slide up. So friction don't want this. So friction will just balance or will act just equal to mg, even if it can act greater than that. Okay, but if F is less than F minimum, obviously sliding will take place. Okay, so let's move on to the next example. In this part, we have to find the minimum force acting on this block at a particular theta. Theta is given to move the block. Okay, so let's just draw and take the components. Draw the FBD. This is F cos theta. This is F sin theta. Okay, this is F sin theta. and this will be normal, this will be its weight, and friction will be acting in backward direction to avoid slipping, and it is nothing but mu n because the case is limiting. Okay, specifically mu s n. So we can say, balancing the upward vertical forces, n is nothing but mg minus f sine theta. So we have reduced the normal reaction, and f cos theta to slide at the limiting case, f cos theta just be greater or equal to mu s n. Again, this is the condition to slide. Obviously, this force must overpower the limiting friction. So we can say, putting the value of n, f should be greater or equal to mu mg minus f sine theta. F cos theta should be greater than this. Just taking f on one side, we can get f should be greater or equal to mu mg by, this is cos theta plus mu sin theta. Okay, so f should be just greater or equal to this force. In the next example, we have to find the minimum possible force and the angle. Now, in this upper example, the angle was given to you. In the lower example, you are free to choose the angle, but the case is the force should be minimum possible. Okay, so again, at any particular theta, the force will be this minimum force. So to minimize this force, maximize what? This part, maximum cos theta plus mu sin theta. The maximum value of cos theta plus mu sin theta is 1 plus mu square, coefficient of this cos square theta and sin square theta. The coefficient of cos theta as 1 square, coefficient of sin theta as mu square. This is the maximum value of this function, cos theta plus mu sin theta. And the maximum and the minimum force, F min, will be nothing but mu mg by root of 1 plus mu square. This is a very, very important and famous expression, and this should act at theta. Again, if you want how I get this, just see a video related to trigonometric expressions. You can easily get the value, or just differentiate it, put equal to 0, get the maxima and minima. And the value of theta for which it will occur is nothing but coefficient of sine, which is mu, divided by coefficient of cos. So at tan theta equal to mu by 1, this force will become this, and this is the minimum possible force with which we can move the block. Okay, and find the F minimum to prevent small m from slipping. These are two blocks placed on a smooth horizontal surface. You don't want this small m to slide down, so you are pushing capital M from behind, and the common acceleration, A common, will be F divided by m plus m. So drawing the FBD of this block, it is getting some normal reaction which is providing the acceleration to the block, which is nothing but A common. mg is acting in downward direction, and friction, as the case is limiting the minimum force, the friction will be limiting mu n, and n is nothing but m A common, and we have friction balance is mg. Mu n is equal to mg. So just by putting the value of n here, we get mu m. A common is F by m plus m. equal to mg. F is nothing but m plus m g into mu. Okay, this is the minimum force required to prevent small m to slide down the this surface. Okay, and if force is greater than that, obviously it will not slide down, the friction will act, which is equal to mg, even though it can act more than that, but the friction acting will be mg only. Okay, if force is less than this value, the block will slide down and friction will be acting as mu kn, which is obviously less than its weight.